Hello everyone, welcome to my YouTube channel. In today's class, we'll discuss about block cipher operation modes. Before discussing operation modes, first we should know what is a block cipher. What is the block cipher? The block cipher is nothing but plain text is divided into number of blocks. Each block will generate individual cipher text. Okay, here plain text is divided into number of blocks. For example, plain text is A, B, C, D, E, F. Then what is the how it will be divided into number of blocks means A, B, C. Okay, this is the cipher text in block cipher. Okay, why? Because what is the original plain text is A, B, C, D, E, F. Here the cipher text is divided into number of blocks. Okay, here a block can be a size block size can be 40, 56, 64, 128, 256. Okay, according to this the blocks will be divided. Clear? The plain text block size is equals to cipher text block. Okay, what is the original plain text size? The same size will be divided into number of blocks. Okay, here the plain text size it should be equals to cipher text size in block cipher. Okay, here the operation modes in blocks cipher we have several operational modes. Okay, what are the several modes mean? The first one is electronic codebook ECB. Okay, the second one is cipher block chaining. Cipher block chaining. And third one is cipher feedback CFB, and it is CBC. And fourth one is output feedback OFB. And the last one is counter CTR. Okay, here we will discuss each and every one by one. Okay, what is the first one is electronic code book. Okay, here what is the electronic code book means? Here the plain text is divided into number of blocks and encrypt the plain text with help of the key, and we get cipher text, and again by using the key you will decrypt the plain text into plain text. You will decrypt the cipher text into plain text. This process will be continued up to first block to up to PN block. First is the up to first block to up to end block. Okay, here this is the first block, second block up to PN block. Okay, here the prop here first what is the first one happening here? The plain text is divided into number of blocks. Okay, what is the plain text here? Plain text is divided into, suppose the plain text is 128 bit. Assume the plain text size is 128 bits. It is divided into 64, 64. This is the block 1, block 2. So it is the P1, it is the P1, T2. Here the P1 is converted as a C1 ciphertext. It is also converted as ciphertext 2. Okay, and finally will add these two and to get ciphertext. Okay, here what is the procedure? Here the procedure is the plain text is divided into number of block 1, block 2 up to block n, and each and every block will perform encryption with the help of the key. Okay, after encryption we will get the ciphertext 1 for first block. Again, the second block plain text will perform encryption with the help of the secret key. Same secret key will get ciphertext 2 and for block 2, and this procedure will be continue up to nth block plain text, and we are applying encryption with the help of key. We are getting the ciphertext n. Okay, up to block n. This procedure is called electronic. This procedure is called electronic code book. Okay, clear. This is about the electronic code book. Okay, what is the second mode? The second mode is cipher block chaining. What is the meaning of cipher block chaining? In cipher block chaining, we will use the first block will given as the first block ciphertext. The first block ciphertext is given as input to the second block XOR operation. Okay, clear. Here the ciphertext of first block will give as input to second block. Okay, see here the in first that again same as the plain text is divided into number of blocks. Here also is the first block plain text with the help of the key we are performing encryption. We are getting the ciphertext. This is the first block ciphertext 1, and this ciphertext given as input to second block XOR operation. Second block XOR operation. Here the block 2 plain text with help of the XOR operation, and before previous block ciphertext we are performing XOR operation, and that result that will be go for again encryption algorithm with help of the key we are performing encryption. That is the ciphertext 2. Again, this second ciphertext will taken as the input to the third block. This procedure will be continuous up to end of the block. End of the block again we are getting this ciphertext as a the ciphertext will goes for the XOR operation, will perform the and XOR operation that will be go to again encryption. We will get the ciphertext. Here the first block not applying XOR operation. Here first block not applying XOR operation. Okay, here we have to take initial vector. We have to take XOR. We have XOR with initial vector. Initial vector. Okay, and in this one plain text is 64 bits, then ciphertext also 64 bits. Why? Because in block cipher, what is the original size? The same size will get the ciphertext. What is the original plain text size? The same size will get as the ciphertext. And finally, after completion of all the blocks, we have to add P1 plus P2 plus P3 and so on, that equals to C1 plus C2 plus C3 and up to Cn. This is the this is the cipher text, and the next mode is cipher feed block. What is cipher feed block? In cipher feed block, the entire block cipher is converted into stream. Okay, it is very fast fast. No need to apply, no need to add any extra bit padding. It is real time application. Okay, see, we'll see what is CFB. In CFB, the plain text length is same as the cipher text. In this, we have shift register operations. The size of the shift register is n bits. Okay, first we have to take initial vector. Okay, the entire block cipher converted into stream cipher. Okay, it is fast. No need bit pairing. Okay, the size of the plain text is s bits, and we will encrypt the n bits of the top register with the help of the key. Then, with the help of the key, then we will get n bits of the cipher text. Actually, the size of the plain text is s bits. So, from the s bits, we have to select most significant bits, MFB. From then, n bits of ciphertext, we have to select S bits. Then the S value should be 1 less than S less than N. Those S bits are perform XOR operation with the plain text. Then the final ciphertext will be given to the top register as feedback. Okay, this is the round 1 operation. In round 1, we'll use initial vector. Okay, here the round 1 operation ciphertext will given as next round shift register. The final ciphertext will given as to the top register as feedback to the second round. The top register will shifting towards the left side because in order to accommodate the ciphertext inside it, again you will have n bits will be encrypted by using the secret key. You will get a ciphertext. In that ciphertext you have to select s bits. The s bits to XOR operation with plain text to get ciphertext. Again we are getting s bits. Again these s bits will go for next round shift register. Again the same procedure will be repeated up to end of the last block. This is the first block, second block, this is the nth block, and finally we will get encryption. This is about the cipher feedback block. Okay, here what happened, the first initial vector we are applying to encryption with the help of the key. We are getting the s bits. In this one we will get most significant bits. Those bits will be applied with XOR operation with plain text s bits. We will get the ciphertext. This ciphertext result will be go for next round shift register. Again the same procedure will be continue up to end of the block to get ciphertext. This is called cipher feedback encryption. Okay, the next mode is OFB. OFB. What is OFB? It is same as Cipher feedback block. Okay. It is same as CFB. Here, instead of plain ciphertext, output given as the feedback form. Okay, in previous one CFB, the output of the ciphertext we are getting the input. The ciphertext is we are taking as the input to the next round. But here we will not taking the ciphertext. We are taking the encrypted data. We are getting as the input to the next round. Okay. Here what is the different here? Here instead of ciphertext, output given as feedback. Okay. The output refers as S most significant bits. Okay. Here next point is output is S bits, M as the most significant bits. Okay. In first round, we'll take non-C as the number in this the first round and non-C and with help of the key we are performing encryption. This cipher text, this output, this encryption output we are taking as the input to the second round, and after that this encryption result we are performing XOR operation with plain text one. We are getting a cipher text, and this X encrypted data will go for input to the second round. Here we are taking the initial vector, but here we are taking the output of the first round. Again we are performing encryption technique. That result will be go for next round. The same data will be we are performing XOR operation with plain text 2. We are getting cipher text 2. Again this procedure will be continue up to end of the last block. End of the last block. Here in each round we will get the ciphertext 1, ciphertext 2 up to ciphertext 1. Okay, what is the ciphertext here? Final ciphertext equals to ciphertext 1, ciphertext 2 up to ciphertext 1. Okay, clear? This is about the output feedback. Output feedback. Okay, the last mode is counter mode. What is the meaning of counter mode? In counter mode, what will happen? In counter mode, instead of taking the plain text directly, we are giving it in the form of counter. Okay, taking a counter and giving a plain text in the form of counter. The counter size is equal to plain text size. It is similar to electronic codebook. Okay, clear? Here counter is placed in each and every block. Okay, see here it is the counter as the plain text, counter as the plain text, counter as the plain text. So what is the first point? Counter is placed in each and every block. Okay, completion of a block, counter value will be increment by 1 each and every block. Completion of a block, counter value incremented by 1. Okay, if first round is completed, the value become incremented by 1. Okay, initially we will take initial vector as a counter. With the counter value, we are performing encryption with the help of the key K, and after that, what is the data we are getting? We are getting the encrypted data. That encrypted data will be applied for XOR operation with the help of the plain text, and we are getting the ciphertext. One is the first round. Okay, the second round, again the encrypted data Again in the second round, again we are taking the counter. This is the initial counter here, counter increment by 1. So counter with the help of the we are performing encryption. Okay, with the help of the key we are performing encryption, and after that we are getting the ciphertext. That ciphertext again we are applying XOR operation with the help of the plain text 2. We are getting the ciphertext 2, and this is the next mode. This is the next round up to nth round. Here we are taking the counter n-1, and we are applying the encryption with the help of the key K, and the result is ciphertext. The ciphertext again we are applying for XOR operation with the help of the plain text and to get counter and. Okay, this is the counter mode. This procedure will be started from starting to up to end of the last block. Okay, initial block we don't have any. Initial block we will taking as the initial vector as the counter. Okay, in decryption the same procedure will be continue to get ciphertext to plain text. Suppose what is the thing here? It is the encryption. So we are taking the plain text. We are getting the ciphertext. Suppose it is the decryption method. We are taking the ciphertext here. We are getting the plain text as the output. Same as here also taking the ciphertext to. We are getting the plain text to. Here ciphertext and we are getting plain text and. Okay, in decryption. The remaining procedure is same in counter block. This is about the block cipher operation. If you have any doubts, please ask me in comment section. Thank you.
నా ఛానల్ పేరు గుర్తుందిగా, ప్లీజ్ లైక్, షేర్ అండ్ సబ్స్క్రైబ్.